In this video, we will look at limit at infinity of rational function. So limit at infinity of rational function. So a rational function is a function of the form of fx is in the form of fx is equals to px over qx. So this is rational function where px and qx are polynomials. So it means that fx is a fraction. So in order to determine the limit of a rational function as x approach positive or negative infinity. So the keyword here is x approaches positive or negative infinity. So first you have to make sure that the x must approach positive or negative infinity. So what we're going to do is we will divide the numerator and the denominator by the highest degree of x in denominator. So the second keyword here is we're going to divide the numerator and denominator with the highest degree of x in denominator. So it's in the denominator. Then don't forget, this method only applies for questions involving rational function. First, it must be a rational function, and x must be approached positive or negative infinity. So there are two conditions. First, it must be a rational function. Second, x must be approaches positive or negative infinity. So let's look at example. Let's say example 1. Determine limit when x approach infinity for the function of 3x plus 4 over x minus 1. So first, like I mentioned before, first this must be a rational function. And the second condition is x must approach positive or negative infinity. So first, it must be a rational function. Second, x must approach positive or negative infinity. So now, you can see that in this example, the degree of x in denominator and numerator are equal. So in the denominator, the degree of x is 1. Same as the numerator. The degree of x is 1. So in this example, we look at the same degree of x in numerator and denominator. So what we're going to do is we're going to divide the highest degree of x in denominator. So in the denominator, the highest degree is x. So means that what I'm going to do is limit when x approach infinity, I will divide the denominator and the numerator with the highest degree of x in denominator. So means that from here, let's say x minus 1. So here is 3x plus 4. So what I'm going to do is I will divide by highest degree of x in denominator. So all of the terms I'm going to divide by x. Because the highest degree of x in denominator is x. So in next step, I'm going to simplify. So 3x over x, here is x, 3 plus 4 over x over 1 minus 1 over x. So 3x over x is 3. 4 over x is already in the simplest form. So here is also 4 over x. X over x is 1. Here is 1 over x. So next, when I try to substitute infinity. So substitute infinity into x. So here will become. So I show you here. Let's see. Example. What happens if I substitute 1 divided by 10? So 1 divided by 10 is 0.1. If 1 divided by 100, 0.01. 1 divided by 1000, 0.001. So you can see that the value or the output is going to smaller and smaller. This is only 1 over 1000. How about 1 over infinity? So this value will getting very small because divided by infinity and very close to 0. Not exactly 0, but very close to 0. So we can assume that this one will approach 0 because infinity is a very large value where the value is not never stop. So 1 over infinity is very close to 0. So we can assume that it will become 0. So from here, what we should do is 4 divided by infinity. So we can assume that this is 0. Same as this one, 1 divided by infinity, here is 0. So what we have here is 3 over 1. So the answer is 3.